In this video, we're going to use the ratio test to find the interval of convergence for cosine of x. So the ratio test, we take the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, which a lot of times just ends up being a sub n plus 1. So here's, and I'll show you something you have to be careful about. When you're putting in that n plus 1, it goes in for n, so you got to be careful of that. A lot of people will write 2n plus 1 without the parentheses, and it's going to cause an issue with your problem. Over 2 times n plus 1, that thing factorial. Now notice I left out the negative 1 to the n. Well, I'm taking the absolute value, so that part's going to disappear anyways. And instead of dividing by a sub n, I'm going to multiply by 1 over a sub n, because that's going to help with my simplifying. So 2n factorial over x to the 2n. Right? The rest is going to be a lot of simplification to see what we can cancel out. So we have the limit as n goes to infinity of the absolute value. Now here, this is x to the 2n plus 2. Down here, this is going to be 2n plus 2 factorial. This is going to be 2n factorial. And this is going to be x to the 2n. So let's see what all we can cancel out. So limit as n goes to infinity. So I'm going to take a step and rewrite this before I do my canceling. This can be rewritten as x to the 2n times x squared. So x to the 2n times x squared. Down here, this can be rewritten as 2n plus 2 times 2n plus 1, and then times 2n factorial. Very important piece when doing these ratio tests is being able to rewrite these factorials. So hopefully you can see where that came from. You'd subtract 1 and you make a product. And I'm not going to go any further because I've gone far enough to see where my cancel is. So the 2n factorials will cancel and the x to the 2n's will cancel. What I'm going to do next is I'm going to pull the x squared out. It does not depend on n, and I don't need the absolute value because x squared is already positive. So now I just need to calculate the limit as n goes to infinity of 1 over 2n plus 2 times 2n plus 1. This limit goes to 0. So this thing is always going to be less than 1. Which gives me an interval of convergence of all reals, or negative infinity to infinity. That's our favorite case. If this limit goes to 0, it tells me that this series converges everywhere.